Alright everyone, welcome back. So in the first video we went through some screening for variables that are going to go into this moderation model. Again, what we're looking at are factors going to be impacting the nature of the relation between thwarted belongingness and perceived support. Again, thwarted belongingness being a variable central to interpersonal theories of suicide and reflecting higher scores on our belongingness variable, indicating greater feelings of alienation, isolation, loneliness from friends, family, other important folks in our lives. And what we're going to be looking at is the impact to which attitudes towards support utilization with higher scores on our NOS variable, reflecting more negative beliefs about the utility of support resources. So I would be reluctant to ask people for help. You can't trust other people with your problems, so on and so forth. And then looking at if there's a difference in the relation of belongingness to SPSS across men and women. So these are our variables. Worked through, took a look at those in the previous screening video, noted some potential difficulties with heteroscedastic errors, talked about some of the implications of that, primarily because we didn't do anything really to resolve that. Our concern here is potential for inflated standard errors for some of our individual significance tests, so we're going to keep that in mind as we're going through and interpreting some of this. But in terms of our moderation analyses, are two questions that we're going to look at in this model. One, to what extent do attitudes towards support utilization impact the association between thwarted belongingness and social support? That's this model right here. And then in the same regression, we're also going to look at whether the relation between thwarted belongingness and social support differs for men and women. And that's going to be this model right here. Okay, so again, we've gone through, screen things. Everything looks okay with aside from the heteroscedastic errors. But we're going to jump right in now and go through, run our moderation, our base moderation model, and then look at our simple slopes. So first thing I'm going to do is I'm going to go back through, first thing I'm going to do is get rid of these variables, left over from our screening, because we don't need those really anymore. And so I'm going to go through, go to descriptives, and I'm going to look at descriptives for my primary predictors in this model. And so I'm going to hit paste here. Alright, and so before I get started in this regression model, what I'm going to do is I'm going to center my variables. Okay, and so what we've got is kind of a curious, well, not a curious situation, it happens all the time, but thinking about what we want to do with our gender variable. Now, gender is dichotomous, right? And so we could just leave gender as a 0-1 variable, 0 referring to women, 1 referring to men, but because we've got two interaction terms in here, what I'm actually going to do, and you wouldn't have to do this, but what I'm going to do is I'm going to center gender. And what that's going to allow me to do is, if I find an interaction between belongingness and NOS, what I can do is interpret that interaction controlling for gender, right? As opposed to if the interaction of gender and belongingness turns up as statistically significant, then we have to start thinking about interpretation of our coefficients at for either men or women. And so what I'm going to do is I'm just going to start out by running my model with a centered gender variable. So I'm going to call this C-sex equals, go through before we do that. Going to run these analyses. Okay, so I can go through and get means. Now, my centered gender variable isn't going to have any real meaningful interpretation because I'm centering a dichotomous variable. But what it's going to allow me to do is just going to control for participant gender in my model. So I'm going to go centered sex variable is going to be equal to gender minus, and the mean here is going to be 0.24. Okay, so this is my command for my centered gender variable, and if I go through and I run this and then take a look at my data, what I see now, and I can go through and sort, so all my women have a value of negative 0.24 on my gender variable, and men have a value of 0.76. Okay, and we'll talk about implications of this as we continue to work through the analyses. So, other thing I want to do, again for interpretation value, is I'm going to go through and I'm going to center my other two variables. So I'm going to say compute. We're going to have centered belonging is going to equal, my belonging variable minus the mean of belonging is going to be 3.0323. Execute, and then compute equals, compute centered NOS is going to be my NOS total variable here minus 44.9731. Okay. All right. So I'm going to go through and I'm going to run my centered variables. Okay. So then again, I see I've got my centered sex, centered belonging, centered network orientation. And then I'm going to go through descriptives. I'm just going to go through to check to make sure that these are centered appropriately. So I'm going to go through, paste, look at these. All right, so everything looks good. Looks like we're a little bit off in terms of our dichotomous variable here, but everything else looks pretty good. So we've centered our variables. So now what I'm going to do is I'm going to create my interaction terms. So compute, and again what we're going to look at is we want interactions between NOS and belonging and sex and belonging. Okay, so these two we're conceptualizing. This is the base relation, and these being the third variables that might impact the nature of the relation between belongingness and perceived support. So I'm going to go compute, and I'm going to call this NOS by belong, or we'll shorten it up, bel, is equal to centered NOS times centered belong. And then we go compute. We'll call this sex by belonging, and it's going to be centered sex times centered belong. All right, and this should go through and no errors. Looks like I entered everything correctly, and so here I see my interaction for belonging and sex times belonging. Okay, so here are my new variables that I've gone through, created for these analyses. Okay, so what I'm going to do now is going to run my base model. So I'm going to go to regression and linear. Whoops, this stuff left over from the screening video here. I'm going to throw these out. And so what I'm going to do is I'm going to go and I'm going to regress my SPSS variable, my perceived support on sex, belonging, NOS, and then my two interaction terms here. Okay. In terms of statistics, well, we can ask for some of this stuff just to leave it in there. I mean, this will be a little bit different because if I have my interaction terms, that shouldn't change anything hugely, but we'll just go through and make sure. So I'm going to ask for part and partial correlations. This is going to be my effect sizes. We'll request confidence intervals because those are always good to have. We'll leave my our plot here that we went through in the screening. So this is just our, on the X, our predicted Y value, or our standardized predicted outcome, and our standardized residuals. Again, that'll be pretty much the same, but we'll leave that alone. I won't worry about saving any additional variables here. Again, we'll leave that to the screening, and then that should look pretty good. So I'm going to hit paste. Here's my regression model, and I'm going to go through and run that. All right. So, taking a look at my model here, starting at the top, here we've got our R-squared value. We're doing pretty good with this model. Again, we noted in the screening high relations between our predictors and our outcome variable, and we're accounting for about 50% of the variability in perceived support with these data. So it's a nice R-squared value, particularly for social sciences research. Our ANOVA table here, our F is massive, telling us that our R-squared value is reliably different than 0, which we probably guessed anyway in a sample of 223, but again, just as a reminder what we're talking about there. And then we're going to go down through and take a look at our coefficient table. Now, if we wanted to go through and take a look at some of the screening stuff, again, all our tolerance values are looking okay, so we're not worried about collinearity, which we have gone through and centered our variables. It looks like with the interaction terms, have a couple of cases with high residual variances. If we go down and look at our scatter plot, looks like we still have that problem with heteroscedastic errors, but we probably expected that to be about the same with this. So again, something that we could go through and look at. We won't focus on that too much here because mostly we're just worried about or want to go through and demonstrate running our interaction or our multiplicative model and then taking a look at simple slopes. So if we go through and take a look at our coefficients, we see that no effect of gender here, belongingness and NOS, or attitudes towards support, are both statistically reliable effects, but notice that we have an interaction of thwarted belongingness and network orientation. Okay, and so it looks like the relation based on this this significance test here, looks like we have a statistically reliable interaction based on these data, which is going to tell us, with the way we've set things up, is that the nature of the relation between thwarted belongingness and perceived support is dependent on the degree to which people's beliefs on these utility of whether or not it's worth utilizing support stuff. So the relation between belongingness and perceived support is dependent on NOS, right? So if we're going through and we're taking a look at some of these effects, so we've got a statistically significant effect of NOS, and we've got a statistically significant effect of belongingness, but these aren't main effects. These are conditional effects because the relation of NOS on our perceived support is conditioned on belonging, in that this relation here is dependent on level of belonging. Same thing, belonging is conditioned effect, in that the relation of belonging with perceived support is dependent on our attitudes towards support utilization. Okay, our gender or our sex effect, this isn't a conditional effect because it's not, at least in our model, involved in an interaction. This is clearly not meeting criteria for statistical significance, but it looks like there's no real gender differences in perceived support across men and women, given the failure of, or at least controlling for these other variables, given that this effect is not statistically significant. Okay. And so here's our constant. Remember, if we're interpreting our constant, we often don't need to, but if you wanting you to know what this is about, this is our expected value for perceived support at average levels of belonging and network orientation, controlling for participant gender and the interactions of NOS and belonging and sex and belonging, right? So going through here are standardized effects. Remember that we can't interpret our standardized effects, or these are not the correct standardized effects for our interaction terms. If we want to get proper standardized effects for our interaction terms, we have to derive those on our own. We'd have to turn everything into z-scores, then create interaction terms with the z-scores, then run my standardized model interpreting my unstandardized coefficients as standardized coefficients in that model. We're not going to go through and do that, but just remember that we're not presenting our standardized coefficients in this base model as standardized coefficients for our interaction terms, because these aren't correct. Okay, but we can go through and see we have this interaction here. Confidence intervals are partial correlations, giving us indices of effect for these different variables here. And so all in all, we're excited. It looks like our interaction of sex and belonging was a bust, suggesting that the relation of thwarted belongingness to perceived support is not reliably different across men and women, but it does look like that. It does look like attitudes towards support utilization does start to impact the association of thwarted belongingness and perceived support, at least within the context of this model. Okay, so we've got one statistically significant effect and the other one that's not. So what we would want to do with this, and again, I'm going to encourage you to always do this even when we're not doing stuff for class. What I would encourage you all to do is to make sure that you're going through and factoring out some of these data by hand. What we want to do is we want to get the simple slopes for the effect of belonging on perceived support at both high and low levels of NOS. Okay, so this is the model that we found our significant interaction for. We found that NOS does impact this relation between belongingness and MSPSS, right? And so now what we want to do is take a look at the nature of that interaction. Okay, and so we're saying, what's our relation between belongingness and MSPSS at low levels of NOS and at high levels of NOS? Okay, so we're looking at our conditional effect at different levels of our moderator here. And so again, because going through and getting these simple slopes, it's just a lot. There's some different calculations that you got to do. You're probably going to make mistakes. I continue to make mistakes. And so it's always nice to have as many double or triple checks as you can. So certainly going to encourage you all to start by going through and factoring out your equation, or factoring out your simple slopes by hand using your base model. So if we go through and we take our coefficients here and plug these into a linear function. So we've got our intercept, our coefficient for centered sex, for centered NOS, centered belonging, and then my two interaction terms. And again, these are just unstandardized coefficients that I'm pulling from here. Okay, and now in this, we've got two interaction terms, so it can get a little bit tricky. But what we're going to do is we're going to go down first and pull down our intercept term. Okay, so we've got that taken care of, right? And then what we're going to do is we're going to pull down all of our effects that aren't related to the conditional effect of interest. So in this case, we're looking at the conditional effect of belongingness on perceived support at high and low levels of NOS. So gender here isn't a part. NOS isn't a part of my conditional effect of belonging, so I can pull that down. And this sex by belonging has this sex term in it. That's not anything we're interested in here, so we can go through and pull those out. So what we're left with are just our terms that have this belonging component to it, right? So we've pulled down everything except the two terms in our model that contain our conditional effect. Okay, and so what I like to do is go through down and just kind of bracket this off and say we're looking at our belonging measure here, or our belonging effect here. And so what we're going to do is we're going to go down through and factor this out. So we're going to bring belonging down, right? And then the interaction, if we factor this out, we've left up with negative 0.343 minus our coefficient for our interaction times NOS times belonging here. And this takes care of all of our terms in our main analyses. And one of the ways you can know that you factored this correctly is if you go through and you multiply out belongingness here, you should end up back at your original equation. So again, this can seem tedious and just doing something to do it, but what this is going to help you do is make sure that whatever simple slopes that you come up with are accurate and that you've got the right thing. There's just a lot that can go wrong in this where you can get turned around. You want to make sure that you're reporting the right stuff. Okay, so then if we go through and we assume that we're holding sex constant at 0, so that's going to be gone. We're holding, and if we hold sex constant at 0, we're plugging a 0 in here, that term's going to go away. If we plug in 0 for sex here, this whole term goes away. And so what we're left with is our simple slope, or what's going to turn into our simple slope for the conditional effect of thwarted belongingness. Okay, so if we think about our reference values for a standard deviation above and below NOS, okay, what we can start doing, because what we want to do is look at the conditional effect of belongingness on perceived support at high and low levels of NOS. What we do is then we just plug, once we get to this point, then we can just start plugging high and low values of NOS into the mix. Remember, because we centered NOS, the mean is 0. So high levels of standard deviation above is just going to be +1 standard deviation. A standard deviation below is going to represent a negative standard deviation. So if we want to look at the conditional effect of belongingness on perceived support at low levels of our moderator, what we do is we take our equation, our factored equation here, drop it down, and then we just plug in low levels of belongingness, which is going to correspond to a value of negative 7.259. So here we throw in negative 7.259 for NOS here. Same thing here. And if we go through and then multiply this out, what we get is our simple slope for the conditional effect of thwarted belongingness on perceived support at low levels of NOS. Okay. Then we can do the same thing at high levels of NOS. All we need to do is, again, now instead of a standard deviation below, we're putting a standard deviation above. So we're plugging 7.259 in here, multiply our factored equation out, and what we get now is our conditional effect of thwarted belongingness on perceived support at high levels of NOS. Okay, so again, I want you to go through, be able to do this by hand just as a double check. And so then once we've got our simple slope equations, what we can then do is go through and plot these. All right. So if we go through and we pull up an Excel sheet, what we've got here, so this is our simple slope for low levels of our moderator, high levels of our moderator. And so we low belonging, high belonging. And so what we've got here is just our, take a look at this. See what I've done is I've entered my simple slope for the prediction of perceived support at low levels of NOS. So we got 5.997 minus 0.270 times times low belongingness and the high belongingness. What this is doing is it's just giving us a point value so that we can graph this slope at low levels of X and high levels of X at low NOS. Same thing here. We've got our simple slope for high NOS. Got this equal to 5.301 minus 0.416 times belongingness. And if we go through and we just have our high and low levels of belongingness, again, this is just a standard deviation above, standard deviation below. This is arbitrary. You could put 2 standard deviations above or below if you wanted a larger range, but this tends to be sort of standard convention how we would go through and do this. And so if we go through, run these in Excel, what we end up with is our simple slope graph for the relation between belongingness and perceived support at high and low levels of NOS, right? So we see at low levels of NOS a weaker relation between belongingness and perceived support. At high levels of NOS a stronger relation. So we see that for those individuals who are wary or suspicious or reluctant to utilize available support, what we see available social resources, we see that these individuals have a stronger relation between loneliness and alienation and low levels of perceived support when people are super reluctant to engage support networks. We still see a negative relation for people who have more positive perceptions or beliefs about the utility of utilizing social networks, but it's not as strong as those people who are really reporting a lot of suspiciousness and concern about whether or not it's a good idea to let people in, let people help you with your problems. Okay, and so all of this we can do just from coefficients in your baseline model. All of this is all that you need to go through, factor out your simple slopes, and go through and plot your simple slopes. Okay. The only drawback here is that we don't know whether or not these slopes are statistically significant. The interaction term tells us that there's a reliable difference, or that network orientation changes the nature of the relation between belongingness and perceived support. That's what we know from the fact that this is a statistically reliable effect, at least in these data. But what we don't know is significance of this, if this slope is reliably different than 0, if this slope is reliably different than 0. Based on our factored equation, we can't really calculate effect sizes for our conditional effect of belongingness on perceived support at high and low levels of NOS. And so what we would like to do is go through and take a look at running this in SPSS in order to get tests of statistical significance, effect size, things along those lines. Okay, we've got the simple slopes. We know what the simple slope is going to be. We just want to get significant values, and we can't derive that just by factoring out our equation. Okay, so what we're going to do is we're going to say, all right, give myself some space here. All right, so what I'm going to do is I'm going to compute. I'm going to create a new variable that's going to recenter the 0 point of my moderator to correspond to low levels of NOS. So what I'm going to do is I'm going to create a new variable. I'm going to call it low NOS, and I'm going to set that equal to centered NOS plus well, actually, before I do that, let me go through and run this once more. Okay, so my standard deviation for NOS is going to be 7.25899. Okay, and what I want to do is I want to recenter my moderator, my NOS variable, so that 0 is equal to a low value of NOS. And so what I'm going to do, remember this is kind of counterintuitive, but what I'm going to do is I'm going to create this low NOS variable by adding a standard deviation. So we got NOS plus 7.25899. Okay, and this seems odd because we say, well, this is low NOS, shouldn't we subtract a standard deviation? But if you think about it, remember, and we talked about this in lecture, that if I'm at a 0 point, right, I'm at the mean of NOS, and so my value in the centered variable is 0. If we add a value of, if we add one standard deviation to everybody else in the distribution, my value, because I'm still at the average, but my value now is, I was at 0, it's now at 7.258. Okay, and 0 value now corresponds to a standard deviation below, and so it's again kind of counterintuitive, but not if you think about it. But just make sure you're doing this correctly. What we're going to do is, so we've got a low So we've recentered our moderator at a standard deviation below and a standard deviation above. And in order to do that, low values we would add a standard deviation, high values we subtract a standard deviation. Okay, so just remember that you're doing this correctly. And then what we're going to do is we're going to create a new interaction term. So we're going to say compute equals, compute, and we're going to call this low NOS by belonging is going to be equal to low NOS times C belong. And I'm going to go compute high NOS times belong is going to be equal to high NOS times C belong. Okay, so what I've done here is I've gone through and I've recentered in order, because what I want to do is I want to run the simple slopes for the relation between thwarted belongingness and perceived support at high and low levels of my moderator. And so what I'm going to do is I'm going to create new variables that correspond to high and low levels of my moderator. So this is my variable that the 0 value now corresponds to low levels of willingness to utilize support and high levels of willingness to utilize support. And then what I'm going to do is I'm going to create new interaction variables with my recentered NOS variables at high and low. And then what I'm going to do is I'm going to rerun my analyses with my recentered two models, one with my moderator centered at low values and the corresponding interaction, one with moderator values set at high values and the corresponding interaction. And this is going to give me the statistical significance of my conditional effect at high and low levels of my moderator. So I'm going to go through, run this, cross my fingers. All right, cool. None of that came up problematic. If I go through and look at my data, okay, so here I have my centered variables, centered sex, centered belonging, centered NOS. Here's my interactions for my base model. But here now I have a new variable. This variable corresponds to low levels, where zero value corresponds to low levels of my moderator. Here's my recentered moderator, where 0 corresponds to high values, and then my corresponding interactions. Okay, and actually, if we go through and we take a look, so I can show you. This might be informative. I hadn't planned on doing this, but we'll do it and see what happens. All right. Well, I know what should happen, but let's say, so here's centered NOS, here's low, and here's high NOS. Okay. And if we go through and make sure I'm getting my histograms here, I'm going to hit OK. All right. And so here, just as a demonstration, so here my 0 value is equal to the mean. And this is a nice symmetrical distribution, so this is easy to see, right? So 0 corresponds to the mean here, but for low NOS, 0 now corresponds to low values, right? I was at the mean, but now the value at the mean, because I added a standard deviation to everybody's score, mean value is 7.26, right? Here, when I subtracted a standard deviation, now 0 value corresponds to high values, right? Again, my mean now is negative 0.76, right? So again, it can be kind of tricky when we're going through remembering that in order to get low values, I'm going to add a standard deviation. To get high values, I'm going to subtract a standard deviation. But if we go through and take a look, again, what we're interested in is where that 0 value is. So here, 0 value is right at the center. Here, 0 value is below once we've added a standard deviation to all the scores. When we subtract a standard deviation to all the scores, 0 now corresponds to a high value. Okay, so you don't need to do this, but if you wanted to go through and take a look, this sort of is a demonstration of how that is all working out. Okay, so what we're going to do now is I'm going to take a shortcut. I'm just going to, actually not, I'm going to go through and I'm going to go analyze regression linear. Okay, so I'm going to keep this, right? And let's just pitch these so we can start from scratch. And so I want my centered sex variable, and I want my centered belongingness variable, because that's my conditional effect right there. But what I'm going to do is I'm going to now look at the simple slopes for the relation between belongingness and perceived support at low levels of my moderator. So I've got sex belongingness, low NOS. I'm going to now put in my low NOS by belonging interaction, and then I'm going to put my sex by belonging interaction back in there, because that was in our original model. We want to make sure that everything stays the same. So plots, I don't need plots. Don't need collinearity diagnostics or case-wise diagnostics. I don't think I saved anything here. No. Okay. So what I'm going to do is I'm going to paste this in. And so we can see, expand this out. So I can see here's my base model, right? We've got regressing SPSS onto sex, centered belonging, centered NOS, and then my two interaction variables. Okay. Here in my simple slopes analyses, I'm regressing SPSS onto sex, belonging, but now low NOS, so low, so my recentered variable for low levels of my moderator, my interaction with my low moderating variable, and then my sex by belonging variable, because that didn't change. Okay, I don't need that scatter plot there, so I'm going to get rid of that. Okay, so I'm going to do this, and then I'm just going to copy that and paste it again. And this is now going to give me, I'm going to take my high NOS variable, place it there, my interaction with my recentered high moderator, replace it there, and now I have my two simple slope regression models. This is going to give me the simple slope of belongingness on MSPSS at low levels of NOS. This is going to give me the simple slope of belonging on MSPSS at high NOS. Okay, so we can go through, run these, and let's see what I get. So, taking a look, so this is my model for low NOS. And so I should see that my R squared doesn't change. That's the same. My F doesn't change. That's the same. My constant will be different, because remember, my constant is my predicted value, my outcome, holding all other variables constant is 0. But what we've done is we've changed what 0 means for my moderator, right? So now 0 corresponds to low levels of NOS, whereas in my previous, or in my base model, it was corresponding to average levels. So we see changes in my constant, right? But what we should see here is the value for, and actually here I'm just going to do this. So we'll go up and run my base model here. I'll get rid of okay. So just clean this up so we can take a look, because this starts to become important in making sure you did things correctly. So we'll go through and run our base model and then our two simple slopes models. So we see for my base model, my R squared value 0.496, that's the same. My F 42.65, that's all the same. My constant, my base model 5.649, that changes, but my value for gender is the same, 0.078. My value for NOS 0.048. My interaction terms, both of them, 0.01, 0.6063, 0.01, 0.063. all those are the same. So the only thing that changes, if I've done this correctly, is going to be my constant and then my conditional effect. In my base model, conditional effect of belonging on MSPSS at average levels of NOS, because NOS was centered, right, was 0.343. If we go down through and we take a look now, we see that my conditional effect of belonging on MSPSS total is negative 0.72 or negative 0.272, and that's statistically significant. Here's my part and partial correlations that I can use as effect sizes. Okay. By contrast, if I go down through and I take a look at the conditional effect of belonging on MSPSS total at high levels, I see that my constant has changed, but my effect for sex hasn't. My effect for NOS hasn't, right? That's still the same. My interactions are the same, but what has changed is my conditional effect of thwarted belongingness. That's 4.13, again statistically significant, and then my part and partial correlations for my conditional effect. But if we go through and we take a look, if we've done this correctly, and fingers crossed I didn't get something out of whack, if I go through and I take a look at the coefficients that I got from, again, my base model, right? This is my base model, and take a look at what I ended up with here, right? This is where I went through and pulled these coefficients for my original analyses. If I go down through and take a look at my simple slopes, I should see that my coefficient, or that my coefficients, my intercept, 0.5 or 5.996, 5.997, negative 0.272, negative 0.270. What I should do is I should match this. These two things should be within rounding error if I've done all of this correctly. Again, just another way to go through and double check. But what I can say now is I know that the relation between or the conditional effect of thwarted belongingness on perceived support at low levels of NOS is statistically significant, right? Because I can go through and I can see that my conditional effect here, statistically significant, associated with a t-value of negative 0.39.912. I've got a partial correlation, negative 0.257, semi-partial here, and so we can report these as effect sizes for the conditional effect of belongingness on perceived support when people are reporting high reluctance to utilize support. Same thing if I go down through and I take a look at my values at high levels. Again, double checking my constant, 5.302, 5.301, conditional effect of belongingness, negative 0.413, negative 0.416. Again, we're really close. And again, if we go through and we take a look here, we see that our, conditional effect of belongingness on perceived support is statistically significant at high levels of NOS. Again, here's my effect sizes for that conditional effect. And so what we've done is we've gone through and we can get our simple slopes by hand. We can calculate those just from our base model, and we can plot that simple slope out, just plotting this at high and low levels. But what we get from the SPSS analyses is we can say that yes, both of these conditional effects are statistically significant. It's just that the relation between belongingness and perceived support at high levels of NOS is a stronger or there's a more negative relation between belongingness and perceived support at high levels of NOS than at low levels of NOS. Okay? And so at this point, we've done everything that we need to do with this perceived support variable, or this perceived support, the conditional effect of thwarted belongingness on perceived support at high and low levels of NOS. Okay, but maybe what we want to do, just for fun, or just because this is an illustrative video, maybe we want to go through and just see what happens if we were to go through and calculate the simple slopes for thwarted belongingness on perceived support for gender. Okay, now this interaction wasn't statistically significant, so normally we wouldn't do this, but because our moderator here is dichotomous, and we centered this to start out with, and so for the purposes of, if you're interested in walking through how to rerun your analyses with a dichotomous indicator here, hang on to your hats because we can walk through that here very quickly. So, or semi-quickly, quickly enough so that you get an idea of what's going on. So if we start out again with our base model that we ran, okay, this is the same model that we ran previously up here, looking at the interaction of belongingness and NOS. Let's say we wanted to go through and factor out and take a look at the simple slopes of belongingness on participant gender. So again, start with the coefficients in our baseline model. So we've got our constant, coefficient for sex, belonging, NOS, and our two interaction terms. Okay, but what I'm going to do now is I'm going to restructure this equation specifically to look at the conditional effect of thwarted belongingness on MSPSS for men and for women. Okay, so I'm going to take the same approach. I'm going to go through and I'm going to pull down my intercept, right? And then what I'm going to do is I'm going to gather up all my terms that don't directly impact this interaction of, or my conditional effect of belongingness and the sex by belongingness interaction. So what I've gone through and I've done, I've added in my coefficient for participant gender, for NOS, and then my interaction term that doesn't involve the effect that I'm interested in, which is conditional effect of sex and belongingness. So I'm going to pull that down. So we've got those terms taken care of. And then what I'm going to do is I'm going to say, all right, I'm still looking at the conditional effect of belongingness, but this time I'm interested in the conditional effect of sex and belongingness. And so what I'm going to do is I'm going to pull down my coefficient for belongingness here, and then from the interaction term, I'm going to pull this down. So now I've got negative 0.343 minus 0.063 times sex, and then we factored belongingness out of this. Again, we know that we've done this correctly. If I go through and I multiply this out, we would end up back up where we started. Okay, so if I multiply this, we got negative 3.43 times belonging times negative 0.063 times sex and belonging. Everything works out. Okay, if we go through and we say, well, we're holding NOS constant at 0, so that term drops out. Again, if we plug in 0 for NOS, this term drops out, and we pull things in. What we end up with is our restructured equation looking at the conditional effect of belonging on perceived support for as a function of participant sex here. And so for your reference values for women and men, recall that with our centered variable, we had coded men originally as women 0, men 1, but when we centered this variable, now women and men take on different values. Women are negative 0.24, men are 0.76. And so to calculate our simple slopes, what we're going to do is we're just going to punch those values because we ran our equation or our model using our centered sex variable in order to get our simple slopes for the relation of belongingness with perceived support for men and women. What we're going to do is we're just going to plug these values from the centered model back in, right? So we're not worried about standard deviation of men and women because that doesn't make sense. But what we can do is we know that women in the centered variable have a value of negative 0.24. So we go negative 0.24 to look at the conditional effect of belongingness on perceived support for women. Plug 0.24 in, get our simple slope for women. Same thing for men. We go through, we plug in values of 0.76 as those correspond to men. Plug those in, work this out, and we get our simple slope for men here. Okay, oops. And so again, simple slope for women, simple slope for men. And if we plot this out, we see something a little bit different, right? Here, we've got an interaction that's 0.04 9, something like that, right? So we're seeing some divergence. These lines don't cross here in the graph, but they're sort of looking like they're going different directions. If we look at the conditional effect of belongingness on perceived support for men and for women, again, remember that our interaction term for the conditional effect of belongingness for men and women, this wasn't statistically significant. It wasn't even close. And we can see that when we go through, if we actually decide to go through and run simple slopes for men and women, we see that these two lines are very similar. They're not perfectly identical, but what this is saying, this interaction, the failure to achieve statistical significance, it would indicate that we don't have, based on these data, sufficient evidence to claim a different relation between thwarted belongingness and perceived support across men and women. And if we go through, calculate our simple slopes, and run these simple slopes, these lines look very similar. There's not much difference in there. And again, we just did this by plugging in our simple slope for women, simple slope for men, and then plugging in high and low levels of belongingness here. Okay. Now, this wasn't statistically significant, but if it were, right, what I might want to do is I might want to, if it were significant, what I would want to do is take a look at the relation of belongingness across men and women. Again, what I would want to do in SPSS is get a sense for whether or not that was statistically reliable. So what I would do, we're pretending that sex by belongingness interaction was statistically significant. What I would do in this case is I would go through and again calculate some different, some new variables here. What I'm going to do first, though, before I do that, I've already got women dummy coded as women 0, men 1, right? But what I'm going to do in order to derive these simple slopes in SPSS, I'm going to insert a new variable, and I'm going to call this gender R. Okay, and so what I'm going to do is I'm going to go down through and I'm going to recode this so that women now hold a value of 1, and men hold a value of 0. Okay, and so now I've got gender and gender R, and I could even go through, and if you wanted to go 0 is male, 1 female, right? So we know what this all looks like, right? Okay, but what I'm going to do now, because I want to go through and I want to test the significance of the conditional effect of belongingness on perceived support for men and for women. So this, with the dichotomous indicator, is actually kind of easy. So what I'm going to do is I'm going to go compute. And I'm going to say I want to look at, for women, times belonging is going to equal gender times C belong. Go through, see, and then, so what I've done is I've created a new interaction variable because we originally ran our model with the centered gender variable because we were looking at the relation of belongingness on outcome controlling for gender. Here, what I want to do is I want to specifically look at the relation of belongingness on perceived support just for women. Okay, and so what we want to do is have women then equal 0 because that's what our regression models are always telling us. Our regression models are telling us the relation of between x and y for all other variables at 0. And so what I can do is I can just take my gender variable, which is already coded 0 for women, and I can create a new interaction term with, we'll call it female times belonging, and I'm going to take my raw gender variable, multiply it by belonging for that interaction term. And then what I'm going to do is I'm going to do the same thing, but this is, I'm going to do this for men. Okay, I'm going to say male times belonging is just going to be my gender R variable. So this is my model where men are 0 and women are 1. And I'm going to multiply that to create a new interaction term. Okay, I'm going to go through, multiply, create these. Okay, and so now I've got two new interaction terms. This is going to be the interaction term I use in my model to look at the conditional effect of belongingness on perceived support for women. And this is the interaction term I'm going to take to look at the relation between belongingness perceived support for men. So if I go here, and I'm going to go just hijack my simple slopes regression from before. What I'm going to do, instead of my gender variable, I'm going to call, or my centered sex, I'm just going to put in gender here, because this is going to be my model looking at the simple slope of belongingness on perceived support for women. Here in my gender variable, women are coded 0, so I'm just going to plug that in. I'm going to go through and put back in centered NOS, because NOS isn't involved in this interaction that I'm looking at. I'm going to go through, make sure I have the right one. My NOS times belonging interaction again, because I don't particularly care about NOS in this model. And then what I'm going to do is I'm going to substitute in my interaction term that I created here. Boom. Okay. Going to do the same thing here for my male model. Except I'm going to look at gender R times belonging times NOS. My NOS interaction, because we don't care about that. But this is going to be my male by belonging, this interaction here. Okay. And so if we go through, and again, run our base model. Get rid of that. Don't want that. Again, this is all just screening stuff that we ran in our original base model. Okay. But then I want to go through and take a look at my simple slope, looking at the conditional relation of belongingness on perceived support for men and for women. And I run this. Okay. If I go through and I take a look at my compare my models, and again, always do this just to make sure that everything's worked out correctly, because sometimes we make mistakes. I should see that my r squared and my f are the same. R squared and f are the same. I should see that my interaction terms are the same. 0.01, 0.063, 0.01, 0.063. I should see NOS be the same. 0.048, because that's not involved in my interaction here. 0.048, and my coefficient for sex, 0.078, 0.078. Those are identical. What I should see differences in are my intercept and my conditional effect, in this case belonging. So we've got 5.649 and negative 0.343, 5.668. So that's changed, and my conditional effect has changed a little. But remember, we didn't find a significant interaction here, so it's not going to change a whole lot, because this isn't actually. We don't actually have evidence that the relation between belongingness and perceived support changes or is different for men or for women. But mathematically, it's going to change a little bit, because this interaction term wasn't exactly 0, right? And so we do see a slight change. Again, this is going to be the conditional effect of belonging. Here is going to be the relation of belonging with our outcome at average levels of NOS at holding sex constant in the model. And so here we've gone down through, and now we're just looking at women. And so this is going to be the conditional effect of thwarted belongingness on perceived support for women. Okay. And again, if we go down through, we take a look here. interaction terms are identical, F's and R squareds are identical, my coefficient for gender is identical, NOS is identical, but we're seeing a slight change in belonging just because we've modeled this in. And so again, because this interaction isn't exactly 0, we're going to see this shift around a lot. It doesn't change much, right? But it's going to change a little bit. And here we see conditional effect of thwarted belongingness at average levels of NOS for men is going to be negative 0.39, whereas it's negative 0.327 for women. Okay, and if we go through and take a look at effects that we got from our hand factoring this out, we'll see for my model, looking at the conditional effect for women, constant's the same, conditional effect, my simple slope here is almost identical. It's within rounding error, right? Same thing for men, 5.59, I'm right on the money there, negative 0.39, 0.391, and so again, we've done this correctly. We've verified that everything adds up the way we want it to. We see that thwarted belongingness holds a negative relation with perceived support for both men and women, but what we know is, given that this interaction term is not statistically significant, we do not have in these data sufficient evidence to suggest that the relation between thwarted belongingness and perceived support is reliably different for men than for women. Okay, so hopefully this makes some sense. Hopefully this was informative. This was a little bit different because we had sort of the same conditional effect across both of our moderators, but hopefully this gives you a sense and helps solidify some of these procedures. Again, the biggest thing is making sure that you haven't made mistakes. So all the double checks that we went through and ran in class and in this video, make sure that you're doing everything in terms of plotting your simple slope, identifying your simple slopes, you can get from your base model. The only thing that you can't get are p-values and effect sizes, and so SPSS provides a way we can kind of hijack that, recenter our moderator to get that data from it. You just want to make sure that you're doing things correctly. So good luck. Hopefully this helps. Let me know if you have any questions, and we'll see you on Wednesday. All right.